Well, welcome to section 2 of chapter 9 on reflections. And in this lesson we are going to talk about a transformation called a reflection, and we will be reflecting figures across a line. So remember, the image before it has a transformation done on it is called the pre-image, and then after you do the transformation it is called the image. Now, in order for this to be an isometry, these figures will be congruent. But one thing that you will notice with reflections is they will have their orientations will be the opposite. What I mean by that, if you look at triangle BUG, when we go in the same direction we get triangle BGU, so it actually flips and goes in the other direction. It goes counterclockwise versus clockwise. So the image and the pre-image have opposite orientations. So a reflection across a line, and this line has a special name called the line of reflection. It has two properties. These transformations have two properties. The first one is if a point A is on the line, so if you have a vertex that's actually on the line of reflection, then its image is the same as the pre-image. And if a point B is not on the line, then it is the same distance. It's on the perpendicular bisector. It's the same distance from that line and is on what we call the line that is the perpendicular bisector of the line. Okay. Here's the first problem. Reflecting a point across a line. If point P has coordinates 3, 4 and is reflected across the line y equals 1, what are the coordinates of its reflection image? Well, the first thing we want to do is plot the point P and the line y equals 1. So I have that here in your notes. You have the point P with coordinate 3, 4, and here is the line y equals 1. Now remember, a line where it's y equal to is a horizontal line. If it were x equal to, it would be a vertical line. Those are things we've talked about earlier this year. So the second thing we want to do is we want to count how far P is from that line and reflect it across the line. So since P is 3 units from that line y equal 1, P prime will be the same distance away and on the perpendicular bisector to that line. So we can see that point P prime has coordinates 3, -2. Here's one for you to try. Pause the video and see if you can do this one on your own. You have point P with coordinate 3, 4. You want to reflect it across the line x equals -1. Remember, that will be a vertical line. So pause the video and see if you can get this one on your own. Alright, hope you gave that a try. Here is your line, x equals -1. And then the point P is 1, 2, 3, 4 units away. So if you go 4 units on the other side of the line, you should get the point P prime. Graphing a reflection image. So here we have points A, B, and C that form a triangle. What is the image of triangle ABC reflected across the y-axis? I've shown the y-axis in blue here in the video. So the first thing you want to do is plot these points A, B, and C and that line, and I've already done that for you. The second step then is to find the coordinates of the image. Okay, so because A prime will be the same distance from A prime will be the same distance from line y equals 1 as A is. So let's go ahead and figure out how far away that is. I'm sorry, I misspoke. This is the y-axis, not y equals 1. That was the other problem. So we are 3 units away. So on the other side, A prime will be 3 units away. Likewise, C prime will be the same distance away, and B prime, since it's on the y-axis, will be its own image. So once you plot those points, you just connect them and draw the triangle. And I've shown that in red. So I would like you to try finding the image of triangle ABC reflected across the x-axis. Come up with A prime, B prime, and C prime, and you're going across the x-axis this time. And bring that answer to class. Here is your lesson check. Be ready to go ahead and turn those in when you get to class tomorrow, and we will see you then.